Hi, in this video, we will be going over topic 4 pseudocode sample question from the IB question bank. We will be solving the question, constructing a pseudocode, and we'll also understand how we go about thinking about these algorithms in pseudocode, specifically in such questions. So I'm going to start with this. Okay. So the question, the situation of the question goes as so. A school has 100 students. All student names, strings, and student ID numbers, 5-digit integers, are held in two separate one-dimensional arrays named SID and SNames. We may need to use reference these collections. Again, these are one-dimensional arrays, so not collections but arrays. They have given us a visual on how they look like, and you can sort of, through your intuition, see how the names are mapped to the IDs. Aaron Zucker has an index of 0 in SNames, so his ID is also at index 0 in SID, right? Both have same length. They've also given us an example of how it is mapped. So you can see that Pia Beranger has ID number 11876. So it's mapped like this. It's mapped like this, right? So it's a good visual relation that you can understand. So it should be easy for you to think of how the names and ideas mapped in the appropriate collections, arrays. So they also tell us that a binary search algorithm is not used to find any particular name in array SNames. This is important because the question here that they give us is, one of the question is, state the reasons for not using a binary search. Also, let me just tell you, this is a 1 marker, while this is a 4 marker. Yeah. So this pseudocode question, constructing an algorithm, I've seen them go from 3-4 marks to 8 marks. So this is on the lower end of the spectrum. So it's a relatively easier question. Okay, let's resume back to our reading. The school offers its sporting program to students and has a basketball team, a tennis team, and a football team. Each student must choose at least one of these 3 sports. The 3 collections, basketball, tennis, and football, are created. When a student chooses a sporting activity, their ID number is added to the appropriate collection. Because the ID number identifies them, therefore they're just using the ID number instead of adding their names, right? This is, again, intuitive. You can understand this. Then they tell us the method is available, where X is a 5-digit integer representing an ID number. Call is a collection that holds student ID numbers, which can be one of basketball, tennis, or football. The method is in returns true if the ID number X is in the collection call, false otherwise. For example, is in, and they've given us examples. So they have example arrays here. So these are example collections, right? This is an example for us, and they then use this example below. Again, they say is in, they give us 2 values here, and they give us what a potential response for it can be. Just again, there it helps in understanding. So if you don't understand what is in method does with from this line, okay, the example is there to help you understand. Very good. The football and tennis training sessions are held at the same time. The football coach would like to know how many students will not be able to attend it. Okay, so yeah, our question is mainly just till here. The 2 parts that we have to do right now, they're only till here. We don't need to read this or beyond that, right? For reference, I'll just scratch it out. So let's start by doing part A. Part A is also till here actually. You don't need to know further for part A, right? So this is for part A. That's still part A, and then this is still part B. Yeah, that's how easy it is. So let's start with part A. State the reason for not using a binary search. We know that they are not using it, so just you need to state a reason. It's a 1 marker, simple. Now, before you actually try and attempt this, you must know what binary search is, and knowing binary search, you must also know the main condition for binary search, the prerequisite, right? So I'll write condition. You don't need to mention the condition itself. I mean, you do. That's how you get the answer. But the condition is that the array needs to be sorted. Only then we can implement binary search. Okay. Now they're saying, again, they're saying for not using a binary search, they haven't actually mentioned which array. Is it SID, S names? So here they tell us that a binary search algorithm is not used to find a particular name in array S names. So if you read it closely, if you read the situation itself closely, you'll understand that they're referring to S names, right? So if you look at S names, um, you're gonna see that it's Aaron Zucker, Carrie Armand, Pia Beranger, Peter Bow, John Buffett, all the way to Evan Apples. So here, if we need to see if they are organized or they are sorted in some order, right? It should be alphabetical order, but they're not in alphabetical order, right? Very clearly, because Aaron, Carrie, and then they have at the 99th position Evan with an E, even though he should be before Pia. So therefore, we know that okay, this is not in ordered in any order, right? Because it's not in any order, we know that we cannot apply binary search here, right? So the simple answer here would be that S names is not ordered. As simple as that. It needs to be sorted, it needs to be ordered. You can mention furthermore in alphabetical order, right? Yeah, this is a very simple question. If you understand binary search, then this is very simple. Next, let's do part B. Now part B is the bigger question. It's a 4-marker, and it's constructing an algorithm. Now this is a question which I've seen students, not this question specifically, but constructing algorithms is one part where students they're not able to do this, right? Mainly because they're not able to think in that manner, how to actually go about solving these. So I'll sort of focus on the instead of giving you a direct answer and telling you how I reach at that answer, I'll go about my thought process. I'll tell you how I think about it. So first thing, again, we have to read this very closely. Once you practice these questions, then you'll understand. Then you won't need to read them as much, or you won't have to think about it as much. You'll just sort of understand, and it'll be part of your intuition on how to go about solving these questions. But for now, let's do it in a more verbose manner. So again, it says construct an algorithm for pseudocode for the method is in. The best part is they've already given you everything you need to know about is in method. So they've done half of the work for you. All you have to do is just convert to code. So the method is in is available. So we know what the parameters for is in are. This is it, right? These are the parameters. And what these params are, that's also given to us, very helpful. They tell us the method is in returns true. Okay, this is important, it's the return value. If the ID, now this is the condition that we'll have to execute, right? If the ID number X is in the collection call, false otherwise. Now if you don't, if this doesn't scream at you, if the question isn't screaming this at you, basically what you have to do is implement linear search, right? All you have to do is do linear search. Since they've already made it clear that binary search is not an option, linear search is the one you'll revert to. And the reason I know it's a linear search is because, again, when binary search is not an option, you'll go linear search. But also, they tell you if ID number X, okay? So they're asking you if this is in this collection, okay? Since call is a collection, it can be any of these. It's a collection with these ID numbers. All you have to do is check if some ID number is in that collection, right? You just have to check if it is in there. You don't have to do any other operation. And if it is, you return true. You just have to search for it. And if it's there, you return true. So this is linear search. But they haven't written linear search. They've just disguised it in terms of just a condition, right? So they do it multiple times in many questions where they've disguised the one algorithm, which you'd probably knowing, in a very sneaky manner, right? So again, it's just linear search. So yeah, they also give you the example. It's good if you understand the example. Again, this is part of linear search only. 11876 is there in the basketball collection. However, it's not there in the football collection. As simple as that. It's there, it's not there. Simple search. Now, once you arrive at what the main logic is, in our case, it's linear search. Now, I'll try and explain to you how you go about writing it as well. So the name is in, okay, is in. Now x comma call, yeah, something like this. Now there's no actually formal there's no formal pseudocode reference for writing a function for declaring a function, but I'll just go ahead and say function is in x comma call, right? I won't write end function right now because we don't know how long the function body will be, right? Okay, so once we do that, again, there's nothing fancy we have to do, just implement linear search, right? If you'd be remembering linear search from your classes, then that's great. The first thing you do, again, this is now what we doing now is this line is something we have to do with all collections. It's just best practice as far as I know. Reset next. Calling reset next on a collection, it just resets the cursor in the collection, which guides you about the current position of the current item in the collection. Again, these are just collection methods. They've told us that this is a collection, right? So we have to use collection methods. So this is something that you have to be careful about. You can't use a collection method on an array, and you can't do what you do with an array on a collection. So once we have reset the collection, okay, we now just want to loop. If you remember what linear search is, you loop through each value in the collection and check through an if condition if that is your target value. Okay, so loop while call dot has next, your collection dot has next. Again, this is a method on a collection. These methods or these collection methods, they will not be given to you in the examination, so you must remember them now or soon enough. Now once we're looping, again, I won't add end loop right now. I don't know how long this body will be. Loop while call dot has next. We now check, we do an if condition. If x is call dot get next, then, okay, so we check if your target value is equal to the current value that we have, then we return true. Now one thing I saw in the mark scheme for this was they had a flag before they reset the collection and did linear search, and they returned the flag itself. They set the flag and then they return true or false based on the flag, which didn't seem as much of a best practice. So if you do end up seeing the mark scheme for this, that's an important thing that distinguishes this answer from that. I'll go over more on that answer in a bit. Now in this case, we have an else condition, we return false, and then we simply end if. It's very important to end the blocks. Then we end loop, and now I'll just do end function to end that function block as well and complete our code. Cool. Now, just if you have some doubts about this, let me explain it to you. We are resetting our collection here. Okay, I'll do it in a separate color. We reset our collection here. Okay, loop while called has next. Okay, we are declaring a loop. We declare a loop. We declare a loop that runs to the entire collection. That runs till the entire collection. To the entire collection. Cool. Again, we're just in these lines. We're just checking if condition, returning if x in call. As simple as that. So this is just three main pieces, right? It's just that this piece is a bit big and the other are just one-liners. So this is all that there is in this question of IB pseudocode. Okay, pretty easy. There's nothing much that we've done. To recap, we went over why they haven't used binary search. Pretty easy. Then we solve a question, pretty much a linear search. Again, practice some more of these and you'll understand. And if you didn't figure it out that it was linear search, just practice these sort of questions more and you'll understand. And if you don't know how to work with linear search algorithm, then just revise what linear search is, what binary search is, sorting algorithms, go over them. And that's pretty much it. That is topic 4 pseudocode sample question from the IB question bank.